we first started our design cycle at the ask stage, our group wanted to make sure we focused not only on the guidelines of the project, but also limiting factors we would face, such as time, money, and knowledge of precision launchers. At our first meeting, we established a tentative meeting plan to follow for the rest of the semester, as well as goals for each meeting for us to reach. During the Imagine stage, we spent a lot of time brainstorming ideas for launchers based on research we did on aerodynamics, energy transfer, and zero energy state. There were two main ideas that we had. One would be a spring stretched back and released to shoot the projectile. The other would be an elastic band on a wooden block that's pulled back. Both firing mechanisms would be set on a track and have a rope through several pulleys attached to our weight. Our release mechanism was two magnets glued between the rope that would come apart after a certain amount of force. We imagined our projectile originally being a Nerf dart, but changed it to a foam ball. Once we picked our firing mechanism to be the elastic bands attached to a wooden block, we moved into the plan stage. We spent several meetings coming up with different sketches for our project's design, as well as materials we wanted to incorporate. We eventually settled on making a 3D T structure for the outline of our launcher, made out of wooden 2x4s. The track would be a metal door slider superglued onto a flat sheet of particle board, and the end of the board would be superglued onto a hinge that was drilled into smaller 2x4s sticking up from the bottom of the T. To keep the board at an angle, we had hammered nails into the sides of the T facing inwards, so the board can rest on them. We started construction in the crafting center, where we spent nearly the rest of our time working on the project. All of our materials were either bought from Lowe's, Walmart, or taken from the craft center. We used drills, files, saws, and an assortment of other tools to construct our project. As we built, we came up with several improved ideas to implement. Two skinny wooden blocks were screwed into the board near the track's exit so that we could attach the bands from the block onto them. This way, the launcher worked similarly to a slingshot, with the two posts being the anchors for our elastic bands. We then superglued two pulleys behind the track and drilled a hole out the back of our T structure to feed the rope through, and drilled the shelf near the hole to rest the weight on. With the shelf made, we were able to find a place for the weight to stay while maintaining the zero energy state of the system. We used a rubber band wrapped around the small wooden posts to hold our projectile so that it wouldn't fall. Our last step involved cutting the rope into two parts and gluing the magnets to both ends for a release mechanism. Once the first prototype was done, we moved into the improve stage. We made sure to prototype individual parts to make sure we could best see the changes we needed. The biggest design change we made was to get rid of one of our pulleys due to too much friction. We decided to switch to having one pulley on the bottom, then feed the rope through another block on the back of the T structure to regulate the direction of the rope when falling. Other smaller improvements, such as adding a nail to the block and bending back a section of the track, were done to help the block hit the ball faster and more accurate. When we originally tested, we were able to get the ball to nearly 15 feet, halfway to our goal. As we made improvements, the furthest we got the projectile to launch was 20 feet, still shy of our goal.
So we encountered several problems during our design process. First of all, the friction between the track and the hitting block significantly reduced the energy transferred into the projectile. Secondly, the hitting block was a little short in height that it only hit the bottom of the projectile, exerted more vertical force than horizontal force, which resulted in the projectile traveling a short distance. Lastly, the pulley that transferred vertical force into horizontal force got detached during our test trials. In order to solve these issues, we not only re-evaluated our design, but also asked for help from others. By doing so, we could come up with the solution that partially or fully resolved the problems. By trimming the block, which reduced the contact between the track and the block, we were able to reduce the friction force between the block and the projectile. We also added a nail to the block so that the nail can hit the center of the ball to launch it with greater distance. However, with the issue regarding the pulley persisted until the design day, we tried different adhesives such as hot glue and super glue, as well as reduce the force on the rope by reducing friction with ribbons between the wood and the rope, yet the pulley still came off after a few trials. After the pulley came off at our first demonstration on the design day, we applied adhesives and sticky tape to keep the pulley intact, which made the later demonstrations possible.
When we arrived at FEDD, we were very hopeful and ready to test our precision launcher. Our first trial did not go very well, and the force on the pulley was too much and it actually got ripped off. However, they gave us a chance to fix it. In our second trial, the ball did launch, but it didn't go as far as it did in our tests prior to FEDD. On the third trial, our rubber bands got twisted and the ball was unable to launch.
Back and make a change to how we did our FEDD project, the biggest thing we would do is put more time into the planning and designing of our project before we actually started building, because once we got to the wood shop, we realized we weren't exactly sure what we wanted our design to look like, and a clear and concise plan would have also helped to make sure all of our team members knew what we wanted the final product to look like, and we would have all had the same vision, because it was a lot more difficult to communicate in words what we all wanted, and it would have been easier if we had better pictures and drawings. Building off of that, doing better calculations would have also helped. It would have taken some of the guesswork out of the building and could have prevented some problems later on when we prototyped. To give advice to future freshmen doing FEDD, I would definitely recommend you start early, because that's what our group did, and it gave us plenty of time to test our project and make modifications as we went multiple times. So if you start early, you can get all of these glitches out of your project ahead of time instead of having to cram it all in the last week before FEDD. Also, I would recommend on your first meeting day, make a specified time and place you're going to meet each week, because that holds everybody accountable and it helps prevent procrastination with the project.